Welcome back to week 6, and in video 2 we are going to get back into some of the information we talked about last week with various scales of atmospheric circulation and how that circulation affects the weather. So if you remember from last week, we had 4 major scales of circulation: micro, meso, synoptic, and planetary. In microscale we had laminar, turbulent, and cyclonic flow. These different microscale patterns are going to help to produce various wind types. Here we have straight winds. Here around a mountain range we might have some turbulence. We'll have some air being churned up. We might see some different types of clouds produced. And then cyclonic flow, we're going to have that spiral flow, which could develop into something larger, maybe smaller wind currents, dust devils, things like that. We also have land and sea breezes. So this brings, during the day, cool air towards the land. Cools the land. We get cloud cover over the land surface because of that rising air due to the lower pressure. And then at night, opposite happens. We have that warmer air traveling out over onto the ocean. And then we have those clouds forming over the ocean instead. And then with mountain valley, similar idea. We have clouds forming over the mountain range. Maybe they rise and cool enough to produce precipitation. We could have precip during the day, cooler temperatures because of cloud cover, and then at night things will clear quite a bit. So this change in air pressure as a result of this temperature difference is what causes the air to flow from high to low pressure. So high pressure, air is cooler, I should say. It's sinking to the surface, and then it travels across to the low pressure where it warms up and rises. So these highs and lows are going to be relative temperature differences, not necessarily hot temperatures or cool temperatures, just higher or lower. So these highs and lows produce what we call synoptic scale flow. So we have cyclonic flow and anticyclonic flow. So we have down and out around around anticyclones, where we have air sinking, clear conditions, whereas around low pressure systems it's going in and up, and we end up having winds and we end up having cloud cover, precipitation as a result of that air rising, cooling, condensing, and forming clouds and precip. So cyclones are what develop into things like typhoons, hurricanes, mid-latitude cyclones that we're going to talk about in the next video or so. And then here's just another image of showing you what some of these cyclones can look like. There's tropical cyclones right here in the tropics, and you can see another cyclone, a mid-latitude cyclone, appear over the Great Lakes. So we also see synoptic scale winds, Chinook winds. So these are going to be bringing mild marine air from the Pacific Ocean, and it will descend and dry and warm as it comes over that mountain range. So we end up with warm, moist air being brought across the mountain range, and then as it drops all of its moisture and starts to sink down onto the east side of the Rockies, it's going to be warmer as a result of that adiabatic cooling and producing. As it adiabatically cools, we have condensation happening, and we can end up having the air warming as a result. There's also Santa Ana winds. These bring hot, dry winds towards places along the coast, like this is in Southern California. As I'm making this video, there's actually wildfires that are developing in California as we speak as a result of this warm, dry air traveling across this part of the country and drying out the land, causing conditions favorable for the spread of wildfires. So Santa Ana winds bring hot, dry air. And then we have nor'easters. Nor'easters are going to be bringing, depending on where you are in the system, some places are going to get blizzard conditions, some places are going to get rain, tornadoes, thunderstorms, and some places are going to get a wintry mix of freezing rain and sleet. And we'll talk about the development of nor'easters and mid-latitude cyclones in our last video of the week. And then lake effect snow, talked about how this forms last week. Lake effect snow patterns bring cold, dry air that actually ends up picking up moisture from the lakes and then drops tons and tons of snow on the eastern side and southeastern side sometimes of the Great Lakes. So lake effect snow brings lots of snow. And then global scale, so last type, this is global patterns of circulation. We're going to talk about this in detail in the next video. So I'll sign off and come back and talk about global scale.